So, mutually exclusive events. So, pairs of events that cannot occur simultaneously. Okay? So you get one or the other, not both happening at the same time. So a couple of formulas that we're going to work with today. But first, identifying if something is mutually exclusive or not. So you're about to roll a standard 6-sided die. E is the event. The die shows an even number. F is the event. F is the event. The die shows an odd number. Can those two occur at the same time? No. So that would be considered mutually exclusive. So you're about to roll a 6-sided die again. E is the event. The die shows an even number. S is the event. The die shows a number less than 4. Can you come up with an example where those two things happen at the same time? Which one? If you roll a 2. Yes. So an outcome for this would be if you rolled a 2. So it is not mutually exclusive. So letter C, you're about to flip a coin 4 times. J is the event. Then at least 2 heads are flipped. K is the event. Fewer than 3 tails are flipped. So the question is, can you get at least 2 heads and fewer than 3 tails at the same time? Yes. So your outcome, it is not mutually exclusive. You could get a heads, a tail, a heads, then a tail. You could list an outcome that is all heads. At least 2, fewer than 3. 0 tails is fewer than 3. So since those 2 events could happen at the same time, we can list an outcome like that. They are not mutually exclusive. So the first thing we're going to do with our calculating the probability is to do it just on mutually exclusive events. But first, you're going to identify these as either mutually exclusive or not and list an outcome. So in other words, can those 2 events occur at the same time or not? Decide what they are. So again, we don't have the full 52 deck cards. We just have the 10 that are listed. So on number 1, is it possible to have a card that is an ace and a king at the same time? No. So that would be mutually exclusive. Event 2, question 2, is it possible to have a card out of those 10 that is an ace and a heart at the same time? So it is not mutually exclusive. Because one of your cards is an ace of hearts. Number 3, is it possible for a card to be a king and a heart at the same time out of those 10? No, because the kings are either a spade or clubs. So this would be mutually exclusive. Again, it's just out of what they've listed, not the full deck of cards. All right, so now the addition rule for mutually exclusive events. So this is the probability of one event or the other event occurring. Okay? So when that happens, we just add the two probabilities. They usually assign a letter to the events. So these, if this addition rule applies, meaning they are mutually exclusive, then we're going to figure the probability. If they are not, we're going to hold on that because we're going to adjust the formula a little bit. So if you're rolling a 6-sided die, event A is rolling an even number, event B is rolling a 3. So can you get an even number and a 3 at the same time? No, because 3 is not an even number. So let's take a look at it. The probability of A is half of the numbers on the die are even, right? The probability of B is 1/6. 3 out of the 6 options. So the probability of A or B, 1/2 plus 1/6 is what? Should be 4/6, which you end up with 2/3. So if you're drawing a card at random from a standard deck, event R is draw a heart, event S is draw a king. So if a full deck of cards, is it possible to get a king that is a heart? Yes. So we cannot use the addition rule. we will be able to answer that question in the next part, where we account for the events that are not mutually exclusive. So letter C. You're rolling a pair of six-sided dice. So this goes back to the table in day one, where you have the sum of the two die. So there's 36 outcomes there. So of this, you're going to roll an odd sum versus the sums that are 10. Well, those would be mutually exclusive because 10's an even. So it's not included in the first. It can't be odd and 10 at the same time. So half of them, 18 out of the 36 are odd. There are 3 events that have a sum of 10. You can get a 4 and a 6. You could get a 6 and a 4, or you could get 2 5s. So the probability of F is 3 out of 36, which is 1/12. So the probability of getting an odd sum or a 10 is adding the 2 of them together, which is going to make 7/12. So one or the other if they are mutually exclusive. So take a look at the next 3. There shouldn't be a double letter on the ace of diamonds. It's just one ace of diamonds. So calculate if they are mutually exclusive. If they are not, we'll get to that later. So we already know which of the 2 we can calculate, because these are the same ones from before. So the probability of E is to get an ace, and that's 4 out of 10. I'll leave it the way it is. Probability of a king is 2 out of 10. So the probability of an ace or a king. Four tenths plus 2 tenths is 6/10, which is 3/5. If it's a heart or a king. So the probability that it is a heart is 3 out of 10. The probability that it is a king is 2 out of 10. So the probability of getting a heart or a king adding the two probabilities together. In other words, half of your cards are either hearts or kings. Questions on those? So if they're not mutually exclusive, meaning the card is a heart or the card is an ace. Well, if I figure the probability of the hearts and I figure the probability of the aces, that means this ace of hearts has been counted twice. So when they're not mutually exclusive, we have to take out the duplicates. Okay. So we're going to extend the addition rule to take out the events that have been included twice. Okay, so we would figure the probability of the hearts, figure the probability of drawing an ace, subtract the probability of getting an ace of hearts, and then we have the actual probability of that happening. So we take out that duplicate. Okay. So for example, if we're looking at this one, so we would, if we go with the adjustment, probability of the hearts is 3 out of 10, plus the probability of the aces is 4 out of 10, minus the probability of it being an ace and a heart, which is 1 out of 10. That's what that does. Because the ace of hearts has already been counted twice in those probabilities. 7, 6. So that'll be 6 out of 10, which is, that's how we can do these if they're not mutually exclusive. Okay. So looking at these, they've given you the probabilities. They've given you the overlapping. So we're still going to calculate the probability of E plus the probability of F. But we're going to subtract the ones that are counted in E and F twice. So the reason why we have to do this is because oftentimes when you add the probabilities, because things are counted twice, you end up with a probability over 1. So when I add this, subtract the overlap or the when it's been included twice, we get 0.85. So if it's an E or G, minus the overlap in E and G, we get 0.8. So I have the probability of F or G minus where it's been included twice. And then we have 0.8 again. Or no, sorry, just kidding, 9. So if we look at calculating this ourselves, do the first one. I would recommend somewhere have a listing of these. So here, just to the side. Let's see if I can get it. All right. So I'm gonna list the color first. So we have a red 1 and a blue A red 1 and a green A, an orange 1 and a green B, an orange 2 and a red C, a purple 3 and a brown D, an orange 4 and a blue E. Just a little bit easier to look through versus having it all written out in the paragraph. So the number is orange or even. So then the question is, do I have even numbers that are orange? Yes, I do. So first thing I need to do is the probability of an orange is 1, 2, 3 out of 6. Which is 1/2. So now I'm going to calculate the probability of an even number, which is 2 out of 6, right? So I'm going to restart. Orange or even. So we're going to start with adding the two probabilities together. Then we're going to subtract the probability of an orange and an even. So how many are orange and even? 2 out of the 6. So when we figure all that, what does it leave us with? 1/2. Again, this last part. Orange and even. See what you can do with those last two. So do the probability just like you normally would. Find the probability of green, or the probability of A, add the two together, and then identify, are there any that are green and A? Subtract that out. So probability that the letter is green. There are 2 greens out of the 6. The probability that you get an A, also 2 out of 6. So the probability that the letter is green or A is 1/3 plus 1/3 minus 1 out of the 6 is both of those. Which is half. So the probability that the number is even, we already have, is 1/3. The probability that the letter is green, we also have, which is 1/3. So the probability of even or an even number or green letter is 1/3 plus 1/3 minus 0. There are not any that are an even number with a green letter. So your final answer is 2/3 for that probability.